All right, but the goal of today is to use substitution to solve systems of linear equations. I already taught you how to solve it graphically and using a graphing calculator. So that you can always use to check your answer. But just know, like on your constructed response or on some of the test questions that are multiple choice or just on the computer in general, it will ask you questions about the process. So you do have to know this method. You do have to know the algebra that's involved with this method. And that's why we are taking time to go over it. Plus, it's really convenient to know more than one method of solving. There's actually 3 methods total. So graphing, substitution, and elimination. Substitution we are looking at today. The math talk is recorded and linked in here. I'm recording right now. I'll also link it in here. The puzzle piece will be lesson 13. You should be able to at least start it today, if you haven't already. We might spill into tomorrow as far as like teaching wise, but I'm not gonna really give you more class time than I've already given you work on your puzzle piece with that. So just keep that in mind. You might have to start it as homework, give you minimal time to finish it tomorrow. The next quiz is planned for Tuesday, and that'll be over lessons 12 through 17. So make sure that you are keeping up with the class, that you're not falling behind, like not doing your assignments for the lessons that we quiz on. Usually means that you won't get a great grade on those quizzes. Also, your assignments are graded on accuracy, if you haven't noticed. It's not just for completing it. So if you are scoring low on your practices, then you will need to ask questions. You need to look over your notes, maybe rewatch the lesson or watch a different video, something. Doing nothing, like you're just gonna get that same score on the quiz. So keep that in mind. And the rest of the dates for the rest of the unit have been set too. So you'll notice unit 2 is a really long unit. October 26th is when we plan to take it, so like a whole nother month. You have to be retaining the information. You have to be keeping up with your binder, which so far is at least 26 pages. Well, I mean, not like as of now. As of now, it would be like 13 pages. But by the end of it, it's at least 26 pages that you need to be keeping in your binder and filling out. You don't get points if there's a blank. So do that, keep up with the class. But on to the lesson. We again did the math talk yesterday, and that's recorded in case you missed it. For substitution, here's just a few steps that you can write down. And if you're a slow writer, maybe take a picture of it. But you should have some free space, whether it's on like the side column or on the back side, to write these steps for substitution. So steps for solving by substitution. That would be like my title. Right, if you have a headphone in, take it out. I'm teaching you something that's disrespectful. I don't think your future employer would accept that, so think about that. All right, so step 1 is to solve one equation for x or y, or whatever variables. There's usually 2 different ones. Solve for one of them. It doesn't matter which one. X or y. Step 2, substitute this expression into the other equation and solve for the variable. What's another word for a substitute? Plug in is what I usually say. What else? I'm hearing mumbling, but can't make it out. Replace is what I also say a lot, but that's substituting. That's a substitution property. When you take something and plug it in, or replace that variable with that expression, then that's called substitution. So step 2, substitute this expression into the other equation and solve for the variable. Step 3, substitute your answer into the revised equation from step 1 and solve for the other variable. Right, again, if you're a slow writer, maybe take a picture and write it down because we're gonna move on. Moving on. 5, 4, 3, 2, 1. So your picture, moving on. All right, the steps are also kind of written in here too, but they're specific to this example, which you could also choose to write down. So a system of equations always has at least how many equations? 2, and they will have the same variable, or at least one of the same variables. If I were to solve by substitution, and you'll see later on that some methods are better than others depending on the system, I'm gonna wanna pick whichever equation I think would be easier to solve for one of the variables. So it doesn't matter, I could choose to isolate x, I could choose to isolate y. Do you think a certain equation it would be easier to do that in? Do you think in the top equation it would be easier to isolate the x or y? Do you think in the bottom equation it would be easier to isolate the x? All right, and why the bottom one? The x is already mostly by itself. I would just have to get rid of the negative 3y, which how would I do that? No. How can I make a negative 3y 0? I would. No, I would add 3y because it's already negative. So if it's already negative, adding the same amount would make it 0. Then whatever you do on one side of the equal sign, do to the other side. So now the x is by itself, which you can see in this equation. Why didn't we add the 3 and 3y to make like 6y or something? Are these like terms? No, one has a variable, the other one doesn't. So don't combine them, just write them next to each other. So now this is my new system of equations. Now that the x is isolated, I could take what x equals, which is the 3 plus 3y, and substitute it or plug it in for the x in the other equation, which is this original equation. So I'm going to do that, plug it in for x in the other equation. That's what it looks like plugged in. Anytime I tell you to plug something in, what do I tell you to always use? Parentheses. Because if you don't, I guess you could get confused. But originally it was 2 times x. So it has to be 2 times what you plugged in. What do you do when it's a number outside the variable? Or not the variable, a number outside the parentheses? You distribute. And then it's 2 times 3, which is, and 2 times 3y, which is good. And then bring everything else down. Usually after distributing, what do you have to do? Come by like terms. What are my like terms here? Good, both of the y terms can be combined. And always keep the sign that's in front of each term. So they're both positive. So they both have pluses in front of them. What's 6y plus 3y? 9y. And then the 6 didn't have a like term, so it just stays there. bring down the equals 15. Now it's just a two-step equation that you can solve. Start with what's farther from it. What's farther from the y. And how do I cancel out the 6? Whatever you do on one side. So that cancels. 9y is by itself. 15 minus 6 is 9. Now keep going. Get the y fully by itself. Opposite of multiplying 9 is, so divide 9 on each side. Y is by itself. 9 divided by 9 is 1. So remember how the answer is where the two lines intersect? Well, the y coordinate or the y value of my coordinate would be 1. Now I just need to find my x coordinate. But now that I know what y is, I can just plug it back into, it could be one of the original equations, it could be the new equation that you made, which is still equivalent. Doesn't really matter. Here they plugged it into the new equation. So then it's just an easy order of operations. You multiply before adding. What's 3 times 1? And then 3 plus 3. So the coordinate, that's my answer, is 6, 1. All right. Questions on the process? So we'll do a few examples together, which these are printed on your paper. So let's start with A. We'll do these together, but you'll help me out. Which equation should I rearrange to solve for a particular variable? Don't call it out yet. Is it about this? Okay. So don't call it out yet. Who thinks we should rearrange the top equation? Raise your hand. Thinks we should rearrange the bottom one. All right. There's no wrong answer, but you'll do a lot less work if you just use the bottom equation. And why is that? X is already isolated. And there's really nothing else on the other side except for the number. So I know that my answer for this will have a -5 in the x equation. Now I just need to substitute that into the other equation and solve for y. Where would it be plugged into? Into the x, because it is x. That's what x equals. So plug it in. Use parentheses, even though sometimes it doesn't make a difference, like now. Right, so this time doesn't make a difference. And solve for y. What's farther from the y? How can I cancel a -5? Adding 5 on both sides would cancel out the -5 because we're trying to get the y by itself. Whatever you do on one side. Good. Y cancels. I have 2y equals with 8 plus 5. 13. Opposite of multiplying by 2. Dividing by 2. And we could leave it as a fraction, but since we're working with coordinates, let's make it a decimal. What's 13 divided by 2? 6.5. So now that you have both your x and y values, write them as coordinates. Make sure you put them in the correct order, and then that's correct. Good, questions on that? All right, I'm gonna have you try B then. So determine which one you want to rearrange, if any. Substitute into the other equation, substitute back to find the other variable. I'll give you 2 minutes. So which equation do you think is easier to isolate one of the variables. Top one or bottom? All right, good. Actually, in both equations, the y is already by itself, so that's nice. So it really didn't matter which equation you picked. But yeah, since this one's equal to just one number, where would I plug it into in the other equation? Into the y, because that's what we said y equals. Also, just kind of, since I already know what y is, stop. Since I already know what y is, I'm going to put it in the y position of my coordinate when I put in my answer. But you plug it in, you get something that looks like this. And solve for the x. What did you get that x equals? Are you sure? Should be a +2 because the negative divided by a negative. So then your final answer written as a coordinate is 2, -1. All right, don't use your note sheet. It'll fill into a little bit of class tomorrow, but we're not spending a whole hour on this. So you want to